So today we're going to keep going with some more work on parts of lines that we've worked on, and gradient is going to form part of what we're working on. And we're going to learn about things that variables, quantities that are directly proportional to each other. So direct proportion is what we're working on today. So two quantities are directly proportional if an increase in one means that we're going to see a similar increase in another one. It does not mean that they're going up by the same amount on both sides. It just means that each variable is going up in the same proportions to each other, the same amounts to each other, but each variable is separate. So here's an example of one. So if one ice block costs 30 cents, then two ice blocks obviously cost 60 cents. Three ice blocks, if we think about it, they're 30 cents each. So 3 times 30 means they're 90 cents, and 7 ice blocks will cost 210 cents, or of course that's $2.10. So you can see as each one is going up, each number of ice blocks are going up, so is the cost. Not by the same amount as each other, but by the same amount on each side. So that is what proportion is all about. Now, an easy way to show proportion and to use it to calculate things is to show the data that relates to it in some sort of table. So in that ice cream example we just looked at, we could display it like this, with the number of ice blocks being our x variable and the cost in cents, in this case, being our y variable. So just like we filled in the little section above, we can fill in this table. So one ice block equals 30 cents, two ice blocks equals 60 cents, 3 ice blocks equals 90, 4 equals 120, 7 equals 210. And you need to notice that with proportion, the values x and y will always divide to give the same answer. So notice that 30 divided by 1 is 30, 60 divided by 2 is 30, 90 divided by 3 is 30. So you can see if we divide y divided by x, should always give us the same answer. And that same answer, or the rate, is known as the constant of proportionality. Now we'll talk more about that in a couple of lessons' time, but understand the amount or the rate it's going up is the constant of proportionality. It's constant, it's not changing, and it relates to proportion. So because they rise at the same rate, the relationship between these variables is linear. So exactly what we've been doing with our straight line graphs, it means it's going to be a straight line. And we can tell that because it is rising by the same rate. So this means how much one variable changes is the same proportion as how much the other variable changes. And on a graph, the part of the graph that shows us how much they're linked, how they're linked, is the gradient. So that should actually say, line, not link. That out. So what it says is the equation of the line shows the rule of how the variables linked. So we've been working on drawing graphs from equations and vice versa, and all this is coming together today to tell you that that rule or that equation tells us how the variables are linked, and the gradient of that line or of that you can pull out of the equation shows how much it's going up by. So you can see it's all linked together. Let's have a go at doing an example of one. Okay, so the rule linking the height of a plant over time is given by h equals 5t, where h is in millimeters and t is in days. So part A, find the height of the plant after 3 days. So we've been given some variables there, which is fine, so we don't need to define them, but we do need to say that we're going to make one of our variables a particular number. So in this case, we're going to say let t equal 3, because t is days and we want 3 days. So we're going to substitute that into our equation. 5 times 3, which equals 15. Of course, we should write a sentence. So therefore the height in 3 days is 15 millimeters. Don't forget to put units on your final answer. Next one, find the time for the plant to reach 30 millimeters and then 10 centimeters. Now notice this time, we're not going to be working with t. This time we're going to be working with h. h is height in millimeters, so we can define that. So in this case, we're going to say, let h equal 30 and substitute that in. So you can see it's really no different than the stuff we've been doing. It's just in an actual context. Now, we should write some sort of sentence too. Therefore, it will take 6 days to reach 30 millimeters. Now 10 centimeters, let's do the next one as well. Now so far we've been working in millimeters and we were told that that's what our variable is. So we need to convert this. So in this case we're going to let h equals 10 centimeters, but we need that in millimeters, which is of course 100 millimeters, 10 times 10. So let's substitute that in. So 100 equals 5t, t equals 20. Therefore it will take approximately 20 days to reach 10 centimeters tall. Okay, so hopefully that's all straightforward so far. Fairly easy to put this into a table. Remember when we did tables at the start? So h equals 5t is our equation that we're working with, and we just substitute t into the equation to find out the answers for h. So for the first one, if t equals 0, then h, let's change that up, h equals 5 times 0, which is 0, and so on like that. I know you guys can do this, so we're not going to spend much time going over that, but make sure you can complete a table. Now, draw the graph. There are various ways you could have done this, but the easiest way is to plot those variables you've just found in your table, so that is what I am going to do. So we need some axes. Now, I'm going to put h on the vertical axis and t on the horizontal axis, because usually you put your independent variable, which is t in this case, on your x-axis, and your dependent variable, the one that depends on how much t is, on your y-axis. So that's where that comes from. So I'm going to go up in 5s because that's what our data is telling us. And for time, I'm actually going to go up in 1s because, again, that's what our data is telling us. So 1, 2, 3, 4, 5. Go up as far as you need to go. Now, plot each one of those points. So 0, 0, might just change color. So 0, 0, 1 and 5, 2 and 10, 3 and 15, 4 and 20. So of course you need to draw a line, and it's going to keep going. That's the easiest way to plot it. Of course, you could have used what your knowledge of line information and to plot it in another way and use rise over run, but you don't have to do that, but you could have, same as before. But something I really want you to note here, note the height and time cannot be negative. So you have to think about the actual problem that you're working with. Height and time cannot be negative, so we only want the positive quadrant. Okay, so keep that in mind. Sometimes, a lot of the time we want the full plane, the 4 quadrants, but in this case it can't be negative height, can't be negative time, so I'm only interested in the positive quadrant and starting at 0. So the last part says find the gradient of the graph. So you will remember that gradient is rise over run. Well, I hope you remember. So there's 2 ways you can do that. You can read it off the graph, or you could use that formula I taught you, which was y2 minus y1 over x2 minus x1. Okay, so if you read it off the graph, which we might do here, rise is how much it's gone up. So if we just use the first 2 points, it's gone from 0 to 5, so that means it's risen 5 places. And if we use the first 2 points as well to find the run. It's gone from 0 to 1 horizontally, so that's moved 1 place. So that means our rise over run is 5 over 1, or of course 5, which is our gradient. And we know that these variables are directly proportional, and we know that because the graph is a straight line. So if we didn't know if they were proportional or not, we could do all of this work that we've done to figure that out. And once we've plotted it and we've drawn a graph, we know for sure that the variables are directly proportional, or they would not produce a straight line graph. So that's how this can be really useful in terms of that. All right, I will do a second one for the rest of it, and we will work through that together. All right.